So, in this video, we're going to talk about the general solution of sine, cos, and tan equation. Let's have a quick review of what does that means. So, if you think about a unit circle, right? And let's say you have sine of x equal half, and you want to know what is the solution. So by definition, sine of something equal half, you know that angle is 30 degree, which is pi by 6. So you know that one of the angle here does equal pi by 6. So that could be a potential solution, right? However, there could be the other side as well that have sine equal half. So we have ASTC. So in the first portion or in the second portion that give you positive sine 1/2. And in this portion, sine the angle will be pi minus pi by 6, which give you 5/6, right? So you know that there's another solution that exists can be 5/6. However, is that enough? No, because you from pi/6, if you go again one revolution, you can repeat to the same position. So pi/6, if you plus 2 pi as the revolution, you can get 13/6. So one of the potential solution is also 13/6. And similarly, 13/6, if you go again one revolution, you will get 25 pi over 6. So you can see this, I can just go on and go on forever, right? And I can do the same thing here, 5/6. If I just add 2 pi on it, I'm going to get 17/6. And then I can have many solutions. So what's the best way to represent the solution? Because I didn't have any domain here. So we call that a general solution. So general means a general way to represent all of these equations, all of these solutions together. All right. So let's start again. Now, how do we represent this sine cos easily? What we do is, so as we know, back to our equation. So sine of x equal half. So we have here that one of the solution is pi/6. So we can say x equal pi/6, right? And because you can go in multiple revolution and every revolution is 2 pi. So you can say, okay, I'm going to plus multiple revolution here to get me to the same position. So I can have 2 pi. And to represent multiple solution, we can call k or n or any letter you want. So I'm going in the textbook, they call it the N. Maybe stick to that. So N is the number of revolution that you will go around and around, and 2 pi is how big is one revolution. Okay, N times 2 pi, and N because N number of revolution, so you can go backward, forward, but you need to go in a full circle. So N is the element of Z integer, right? Which means n can be, 0, 1, 2, -1, -2, and so on. All right. Now to make it nicer, instead of writing n times 2 pi, you can write that. You can write that 2 pi n pi. Okay, look nicer. Okay. Then you do the same on the other side. So one of the angle on the other side is 5/6. So I could have x equal 5/6. And to represent multiple solution at this point, I could be adding 2 n pi. So these are called general solution. Okay. Now this is for sine, and for cos, you do exactly the same process. But if I maybe before we move to 10, we're going to do some of these together first. So find the general solution for cos of x equal a half. So the reference angle for a half will be pi 60 degree, which is pi over 3. So we know one of the angle is pi over 3. Now we want positive cos, so we have a STC. So we could have the angle in the on quadrant 4 as well, which is 2 pi minus pi 100. That gives you 500. Okay, so we write f, whatever that is here, x equal pi 100, and then we just plus 2 and pi at the end to represent the general solution. And you do the same thing here, x equal 500, and then you just plus 2 and pi. And n is an element of z. All right. Now I'm going to talk about tan because tan is a little bit different. So you can see for cos, you can end up having two solutions. So what about tan? So let's do question B. Okay. Here, there's a root 3 here. I'm going to take the root 3 over. So I would have tan of 3x equal 1 on root 3. Right? Now the reference angle to that will be 30 degrees, which is pi 6, right? Now, as you know, we want tan to be positive, so we can have quadrant 3, right? So in this quadrant, you could have pi plus pi 6, which you end up having 7 pi 6. So technically, you could have written as two general solutions, but because the special thing about tan is you can see to go from pi 6 to 7 pi 6, you just need to go half of the circle. And then if you go another half of a circle, you repeat the same position. So technically, you don't need this. You can use pi 6 and then you pass half a circle to get the next solution, which is 7 pi 6 here. And then if you pass another half circle, you get that. And we know that one half of the circle is pi. So you could, and so for tan, we only have one general solution for that reason. So we going to have pi 6, okay? And to represent the next point, which is half a circle, and half circle equal pi, as you can see. And then you just need to time by how many half circle you need, so which we call that n. So the general solution for tan, we only have one, which is pi 6 plus pi n. And n is the element of z, right? Okay. Now here we have an example here. Find the first three positive solution. We want positive and we want the first three positive. So we want the smallest, the first three smallest positive number. If I do, let's do this again. So cos of x equal a half. Previously we talked about a half is the angle is pi 100 and cos in quadrant 4, which is 2 pi minus pi 100, that gives you 5 pi 100. So we written as two general solution. And you can see here why they can't combine this and this, because this is, can you see that the half, this is a lot bigger than the small part here. So it's unevenly divided. Whereas tan, for tan, you actually divide it in half and half. All right, let's get back here. So you have pi 100 plus n times 2 pi, or might write that 2 pi n, okay? 2 n pi. Or x equal 500 plus 2 pi n, and n is the element of z. Now we want the first positive. So as I say, n can be 0, n can be 1, n can be 2, n can be a negative number. All right. So if we start from 0, n equals 0, you're going to have x equal, if you sub 0 in, you will have 100 because the whole thing here becomes 0, right? And you could have, if you sub 0 in here, you would have 500. So they positive, that's for sure. But they want the first three positive. All right, now if you increase n equal 1, if you think about substitute n equal 1 in here, so replace that as number 1, you will have pi 100 plus 2 times 1 times pi. So pi 100 plus 2 pi, that gives you how much? 6, 7 pi 100. Okay. And if you do the same thing here, if you do 1, 2, so you have 500 plus 2 pi, that gives you 11 pi 100. All right, so we have more positive solution here. What about n equal negative? If n equal -1, think about if you substitute n as -1 in, you're going to end up having a negative solution. Because think about if you have -1 here, pound 3 times pound 3 plus -2 pi, that will give you a negative. So you don't want anything negative. Okay. Now, so we want the first three positive. So this is pound 3, that's the smallest, 5 pound 3, and 7 pound 3. So we don't need this. Right. I just do one more for general solution for the last two example. Here, for psi of something equal √3/2, and we know the angle for that will be 60 degrees, so pound 3, right? Now, because psi is positive, so you also want quadrant 2 as well to make psi positive. So in this quadrant, it will be pi minus pound 3 is 2 pound 3. So you write x minus pound 3, you equal the angle here, which is pound 3, and you just need to plus 2 and pi at the end, okay? Or x minus pound 3, and you do the other one, which is 2 pound 3 plus 2 and pi, and n is element of z. Now you solve for x, so you move pound 3 to the other side, so you get x equal 2 pound 3 plus 2 and pi, okay? And then you solve for x here, move that over, pound 3 plus 2 pound 3, that gives you 3 pound 3, which is pi, 2 and pi. And then, so these will be your general solution. And you just need to write n is belong to z, okay? Oppositely, if we have to do for 10, for question B, as I said, 10, you only have one general solution, okay? So, and the period for 10 is pi. So we have the reference angle for 10 equal 1 is 45 degrees, which is pound 4 right here. So because 10 is positive, so you have the other angle as well on the other side. But because they can go half of the circle evenly, so you don't need another solution for this to represent. You can just use pound 4 and add half of the circle to represent the next solution. So what we do is we have 2x minus pound 3 equal pound 4, and we just need to plus n pi. Okay, so for 10, just plus n pi. And then we solve for x, we plus pound 3 over 2x equal pound 4 plus pound 3 plus n pi. Pound 4 plus pound 3 is 7 pi on 12 plus n pi. Then we divide it by 2 on both sides. So if we divide it by 2 here, we get 7 pi on 24 because we multiply by half. And we divide it by 2 here, we get n pi over 2. So this will be your general solution, and n is the element of z.